Hi YouTube, I hope you all guys are doing great. In this video we are going to see how we can connect our MongoDB with Langchain. For this video we are going to use the raw data of MongoDB and I'm going to use the Compass version. Now why actually there is a need to connect the MongoDB to Langchain, let me explain and give you a scenario or example. So let's suppose you are creating an LLM application and you have two data parts. Let's suppose first one is static, which will not change time to time, and second one is your dynamic data, which keeps on changing minute by minute or hour to hour. So let's suppose you are trying to develop a Langchain application where you are going to suggest a product, and let's suppose you have stored all the data of your products in your vector DB, which is the static part, and basically you are suggesting, let's suppose, XYZ product. Okay, now what you want is, for this XYZ product you want to see in your inventory, which is maybe stored in your SQL database or NoSQL database like MongoDB, and you want to see the price of it or whether it is available or not, because this kind of data or a parameters like whether it is available or not, the price, they are very dynamic part. So it's very easy to store in the raw format rather than storing it in the forms of vector. So in this case we need to connect our Langchain application with the MongoDB application, MongoDB or maybe SQL databases like MySQL. So if you see MySQL, then in Langchain a lot of agents are there, chains are there, like SQL database chains. But for MongoDB there is no such agent as of now, or connectors, or like chains as of now. So that's why there is a need to connect our Langchain application with MongoDB. So we are going to use the same approach which Langchain uses in case of SQL database chains or the SQL agents. Like whenever you ask a natural query like give me the price of XYZ, so now you are giving a natural language query. So first of all, it makes an LLM call and it forms a query in case of SQL, and then it fires to your database and gives us some response from the database. In the similar fashion, what we are going to do is, first of all, we will take a natural language query, we will use a LLM like GPT 3.5 Turbo or something else, and then we will form a NoSQL query. And then after forming the NoSQL query, we will fire it to our MongoDB database using any kind of programming language. In this, we are going to use Python. So now for this part, we are going to develop a chain that will be our MongoDB chain. And this part is very easy. If you get a query, then you can easily fire it to your MongoDB and then you can extract the data. Okay, so let's see how we can do all these stuffs, and definitely you can find all the code in this GitHub repo. I will be providing the link in the description box. So now let's see. So I have created a database in MongoDB. So the database name is DB trial and the collection name is DB trial CL. Okay, and here I have made two documents. So both are kind of same documents, like having name, industry, founded year, employees, headquarter location. Then we have products. We have three products of this company. We have revenue, CEO, and inside CEO we are having name, age, email. So proper nesting is also there. Then in department, the first department, there is engineering, employees, and then also inside it we have manager and their email ID, like this. And similar kind of data we are also having here. Okay, the schema is same, and I think the whole schema of collection should always be same. Okay, so now let's see what we are going to do. So this is our MongoDB part. So you should definitely have a MongoDB Compass and you should have some data, okay, to play around it. Now let's see what we are going to do. Before moving to the main code, let me explain you this config part. So in this config part, we are going to have an OpenAI key, because we are going to use the OpenAI models. If you want to use any other LLM models, you can go for it, like Hugging Face or something else. Then we are having MongoDB URI, which is our MongoDB URI, like localhost 27017, the server. Okay, then we are having the DB name, which is DB trial, collection name DB trial CL, And this is important, table schema and schema description. So table schema is this, like what is ID, what is name, what is industry, and schema description is some more descriptive information about what actually stored in collection, what actually stored in founded year. So here you can see like ID is a string, name string, industry string kind of thing. And then in schema description we are having here is a description of to determine what each key represents, like what actually industry represents. It represents the industry in which the company operates, founded year in which the company was founded, kind of thing. Okay, it helps the chain or the prompt to understand which kind of DB collection we are, or the schema we are going to play. Then we are also having a few short example. Why we are having an example? To basically explain our LLM model that okay, if you are receiving this kind of question, so this is one of the example that we are giving. Okay, so if you don't know about the prompting techniques, you should learn about it. Like it comes under one shot. Like what actually one shot is, like what actually is prompt. Okay, so prompt is basically to give instructions to your LLM model. Now when LLM doesn't perform with the basic prompt, we go for some standard techniques like few shot, one shot, two shot. So we give one example. It happens now whenever you explain something to any human being, then maybe he doesn't understand in the proper way. But if you give an example, there is a high chance that the other person can easily understand it. In a similar fashion, we sometimes even give examples to the LLM. Okay, so this is our config file, and definitely you should have a proper OpenAI. Okay, so now let's see the main code. Okay, so first of all we are going to use chat OpenAI. You can also use OpenAI. Then we are having LLM chain, prompt template, and JSON, and some basic import statements are there. And you should have PyMongo, because we are trying to connect Mongo with Python using Python language. And then because all of our key are in this config data, so config file, so we are importing import config data. Then we are creating a LLM OpenAI chat. We are trying to access GPT 3.5 Turbo 0125. You can also go for any other GPT 3.5 Turbo model, but I found that 0125 works good in this use case, so that's why I'm using it. You have to also pass your OpenAI key, which is stored in the config file. Then we are just creating some variables, table schema, config.table schema. So basically whatever table schema it is in the config data, so we are extracting it. Then we are having we are trying to access the schema description and few short examples. You can also keep all the, without making config data config file, you can keep all things here also, but to look better I have kept here. Like in config data, all the data are which should be provided by the admin. Okay, then whatever example we are having, we are converting it into JSON. Why we are converting it into JSON? Because we have to pass it in a form of variable. Now we are having a prompt like you are an expert in crafting NoSQL queries for MongoDB with 10 years of experience, particularly in MongoDB. Why I am writing this? Because the NoSQL queries depend upon platform to platform. Now I will provide you with the table schema and description in a specified format. Your task is to read the user question, which will add to certain guidelines or formats to create a NoSQL MongoDB pipeline accordingly. We are trying to create a pipeline. Okay. Then we are passing table schema as of in the form of variable, and schema description in the form of a variable. And here are some examples. So this is why few shot is important. We are trying to, this is not necessary for any kind of prompt, but if you are trying to give some example, which is called as one shot, if you are giving one example, if you are giving two example, two shot, if you are giving more number of example, which is called as few shot. Okay, so name of the departments where the number of employees greater than 100. Okay, so if you see here, so a lot of departments are there. So name the department where the employees are more than 1000. Okay, means the engineering department will be there, marketing department will be not there, and sales department will be there. So that's why I have created a query, and that query is basically I am passing here. Okay, so in the JSON example string, which is in the config data file, which I have just shown you. So I have created a query so that the LLM can understand, okay, I have to form query in such format. Then I'm giving some note like you have to just return the query, nothing else. Don't try to return any additional text with the query. Sometimes it gives some additional text like this is your answer or something like that. Okay, then we are passing user question. So this is a very basic technique if you know about Langchain. So we are creating a prompt template, we are passing the template this template, and we are passing input variables because we have 4 input variables in user question, JSON example string 1, table schema, and table description. So if you see the prompt, so let me run it. So if you want to see the prompt, so this is the way, like prompt.format, so whatever prompt it has made. Okay, so this just whatever we have created, this is a way to just show. Okay, now we are creating LLM chain. Okay, and if you don't know about prompt template, LLM chain, just you can watch my basics video where I have clearly explained in 2 videos about a lot of things about Langchain basics. Okay, so we are creating LLM chain. Now we are passing LLM OpenAI and whatever the prompt we have created, and we have making the verbose true because we want to see what is actually happening in the under the hood. Okay, then here we are creating a function named get query, and we are passing the user question. So this line defines a function named get query that takes one argument, user question, and then the next line is like response is equals to llm chain dot invoke. This line calls invoke method of the llm chain object. Okay, which is instance of class. Okay, passing it a dictionary containing keys such as user question, JSON example string 1, table schema description because we want it. Okay, and it then stores the result in the response variable. So here we are having response text. So then the another line which is response text dot replace output, because basically this line extract the text key from the response dictionary and removes the substring output, because in response I was getting output many times, so I don't want output, I just want the query. Okay, then we are also having a regex part. So whatever we are getting from here like response text, we want to form a regex here. Okay, so just a regex because a lot of time I was getting some collection name dot aggregate and something like that. I don't want it, so that's why I have added some regex so that I can get the required things. Okay, so basically if you don't understand this line, basically this line defines a regular expression pattern that matches a specific string. Okay, like the prefix indicates a raw string which is often used for regular expressions. Okay, so we don't want it, so that's why we are removing it. Okay, and at the end basically json dot loads output string. So this line basically converts the output string into Python object, so a dictionary or a list using json.load, and it returns the get query function. Okay, so this is a very basic thing. Okay, like these are some thing which I have figured out, like initially in my response I was getting output and something like db.collection name dot aggregate, which I don't want in on the query. I just wanted a plain query. Okay, then basically overall you can say this function seems to take a user question as input, involves LLM chain with additional information, processes the response text, and returns the result as a JSON result. Simple. Okay, JSON object. Then we are having like some lines like client is equals to pymongo.mongo client config database mongodb URI. So we are passing the mongodb URI, then we are passing db name, and we are passing the collection name. Simple. Okay, then we are here passing the main user question, like when innovate tech solutions founded. So let me run it once, and this also, and let's see what actually is happening under the hood. So here you can see like we are entering into LLM chain and you are an expert on something like, and this is the table schema. So let me put into the scrollable element. So this is the schema description that we have passed in the form of variable in our prompt in our chain. Okay, now here you can see if you want to see what query it has returned, so definitely we can print our query one. So let's print it and let's see what query we are getting. Okay, so query one. So let's see what query we are getting. Okay, so we are getting like this dollar match name Innovatech solutions and project founded year 1. So this is what query we are getting, and this is obviously the correct query. So now we are trying to fire that query in our MongoDB. So let's see how we can do it. So this is, we are getting a pipeline. Okay, so the first line, which is pipeline, is equals to query 1. So this line assigns the value of query 1 to the variable pipeline. The query 1 variable likely contain an aggregation pipeline, which is a list of stages that MongoDB uses to process the documents. And then second one is the result is equals to collection name dot aggregate, and we are passing the pipeline. This line used to aggregate method of the collection name, the collection to execute aggregation pipeline defined in the pipeline variable. The aggregate method returns a iterable cursor object. If you print it, you will get a cursor object representing the results of the aggregation. At the end, what we are going to do is like for doc in result, so that this line starts a loop that iterates over each document in the result cursor. Then print doc, so that this line prints each document in the result cursor. Each document is a Python dictionary representing a document from the MongoDB collection that matches the aggregation pipeline. Overall, these lines these lines are an aggregation query of an MongoDB collection using an aggregation pipeline and prints the result. Okay, if you don't know about pipelines and all, so in MongoDB, an aggregation pipeline is a series of stages that allow you to process and transform documents in a collection. Each stage in the pipeline performs a specific operation of the documents. Okay, so if you don't know about the collection name dot aggregate pipeline, why we are doing it, so this method used to apply this pipeline to a collection. It takes the pipeline as input, like the query as input, and then executes each stage in the pipeline or in the documents or on the documents in the collection. Okay, for example, if you have a collection of documents representing sales data, you can use an aggregate pipeline to calculate total sales for each product category. Each stage in the pipeline might filter, group, and sum up the sales data to derive the final results. In simpler terms, think of an aggregation pipeline as a set of instruction or a recipe for MongoDB to follow when processing the documents in your collection. The aggregate method is like pressing the start button that tells MongoDB to start the following instruction and produce the desired output. Okay, if you still don't understand, please go through some queries and just play with MongoDB, how using Python, how you can query your MongoDB. Okay, so now let's see what response we are getting. So we got a response like founded year is 2008. So let's check for Innovatech. So this was our this is our Innovatech solution. So it is founded in 2008. Okay, now let's ask for products of this big tech company. So let's see. Okay, let me copy it and let's move. So let me ask what products do offer. Okay, so this is basic natural language query that user can ask. So it has formed some query name big tech inclusive project products ID. Okay, so now let's run it. So here you are getting like products is big tech OS, big tech cloud, and big tech analytics. So definitely it's correct because they are having 3 products. Now let's see some more better questions. Like we can ask like some nested questions, like something like if you go to CEO. Okay, so email of CEO. Okay, we can ask. Okay, so email of CEO of big tech inclusive. So let's ask question like what is email of CEO of big tech inclusive, or whatever it is. Okay, big tech company. So let's see what it is getting. So it has given john.smith@bigtech.com. so definitely this is the correct one. Okay, now let's ask some more complex questions like which company is having younger CEO. Okay, this sounds interesting. So let's ask which company has younger CEO. Okay, so now it has to process both the documents and then it has to take some decisions. Okay, so here you can say like it has given Innovatech solution and the CEO name is Emma Lee, age is 48, and her email ID. Okay, so and definitely because we have 2 CEOs, first one is John Smith and second one is Emily, which she is the CEO of Innovatech Solution, so that's why it gave her age and all things. Okay, now if let's ask some more questions like out of this both documents, how many companies are how many departments are there which has more than 1000 employees. So here you can say we are having four departments. In the first document we are having two departments that are having more than 1000 employees, sales and engineering. And if you see here we are having I guess we are having more, like all the four departments are having more than 1000 employees. So it's better we can ask how many departments are there which are having employees more than 1500. So you will get one from here, and here we will get two. Okay, so there should be three answers. Okay, so let's ask how many departments are there, how many departments are there having more than 1500 employees. Okay, so let's see how many departments are there. So let's see. Okay, so number of departments is 1 and 2. Okay, so in the first I guess in the first document it has one department, and in the second it has extracted two departments. So here you can see, like in the first document we are just having a one department which is having more than 1500 employees. So this is the only we are having one department, and here we are having just two departments. Okay, so it has given the number. So let's ask like how many departments are there having more than 1500 employees, and also provide their names. Okay, so let's see. So here you can see, so the count is 1 in the first document, and the department name is engineering, because we have just one department which is having more than 1500 employees, which is the engineering one, because it has 2000 employees. Okay, then if you go here we are having development as well as the sales. Okay, so development and sales. Okay, so pretty good, we can extract a lot of things. Okay, I know this is not the perfect solution, okay, because if you ask very complex query it will fail, but for such kind of query it is also a complex query. For this kind of queries also it's working perfect. Okay, now let's ask some more questions, some more nested questions, like we can ask like manager. Okay, so let's ask some questions like in Innovatech Solution, let me frame a question like tell me the manager email or manager names of Innovatech Solutions, or tell me the name of manager names of Innovatech Solutions that are having more than 1500 employees in their department. Okay, I don't know whether this question is correct or not, but I think you will understand what I want to ask. Okay, so here we are asking like tell me the manager names of Innovatech Solutions that are having more than 1500 employees in their department. So first one is Michael Chen and Daniel Thompson. So let's see. Okay, so if you see in Innovatech Solutions, so first is the development branch, so it has also having more than 1500 employees, so Michael Chen. And second is this sales part, so Daniel Thompson, which is having this department is also having more than 2000 employees, so we have got Daniel Thompson. Okay, so these are some good complex queries, and this kind of approach works very fine. So that's it. Okay, and if you are not getting that desirable answers, then what you can do is There are a lot of things. Okay, this is just a section where we have seen like how this chain approach can help to connect with MongoDB. You can also create some custom agent, okay, MongoDB agents of your own, okay, so that you can communicate with your MongoDB database. But I'm not going to talk a lot about this custom agent in this video. Okay, this can be preserved for some other video. And still, if you are not getting some pretty fine results, then what you can do is you can also do fine tuning. You can take some pretty good 100 or 200 examples of natural language query as well as their MongoDB or NoSQL query, and then you can also fine tune the models like Google Plenty 5 Excel or something like that. Okay, but still if you are using GPT 3.5 Turbo 0125 as I have just shown you, it's working quite perfect. Okay, so it's better to use this. Okay, if you still want something much better, then you can also go for the fine tuning pathway, but definitely it needs some investment. Okay, I hope you have learned something in this video, and if you have learned something, please give it a thumbs up, and if you have still any doubt, you can ask in the comment section. I feel very happy to help you all guys, and next video, till then, bye bye, thank you.